Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the concepts of derivatives from first principles to solve this word problem. So as per the problem, a football is kicked up into the air. Its height h above the ground in meters at t seconds can be modeled by h at t equals 18t minus 4.9 t squared. And we have to find the prime of h at 2, and we have to find what does prime of h at 2 represent. So let's start with part A. So in part A, we have to find the prime of h at 2, so which is the first derivative of the h function at t equals 2 seconds. So the first step here is to write the expression for the derivative of a function using the first principles. So the expression is, so since we are given the function h at t, so the derivative of h at t will be the prime of h at t equals limit h approaches 0, and then the function h at t plus h minus h at t over h. Now we have to find the derivative of this function at t equals 2. So we can sub in t as 2 in this expression. So we get h of prime at 2 equals limit h approaches 0. So then h at 2 plus h minus h at 2 over h. Now we have to find the expressions for h at 2 plus h and h at 2. So let's start with h at 2. So we can sub in t as 2 in this given equation for h. So we get 18 times 2 minus 4.9 times 2 squared. And now we have to evaluate this expression. So 18 times 2 is 36 minus, and now we do 4.9 times 2 square, which is equal to 19.6. And now we can subtract these numbers. So h at 2 is equal to 16.4. Now we can find the expression for h at 2 plus h. So for that, we will sub in t as 2 plus h in this given function for h. So we get 18 times 2 plus h minus 4.9 and then 2 plus h squared. Now I just want to make a distinction. So we are given this function as h at t, but when we write this expression for the first principles, so limit h approaches 0. So this h is not this function. So this h is just a small quantity that we use to find the slope of the tangent or the derivative of the given function. So I just want to make sure that there is no confusion on that. So now we have to simplify this expression. So in the first parentheses, we should distribute the 18. So h at 2 plus h equals, so 36 plus 18h. And now in the second parentheses, we can distribute the square. So 2 plus h times 2 plus h. And now we get h at 2 plus h equals, so 36 plus 18h. Now we have to distribute the terms in the parentheses. So we have to use the FOIL method, 2 times 2 times 2 times h, then h times 2, and then h times h. So in parentheses, we get 2 times 2 is 4, plus 2 times h is 2h, and then h times 2 is 2h, and then h times h is h squared, and then close the parentheses. Now we can distribute this 4.9 into the parentheses, and we can also combine the 2h in the parentheses. So we get h at 2 plus h equals 36 plus 18h, and now we get negative, so 4.9 times 4 is negative 19.6, then negative 4.9 times 4h, so that will be negative 19.6h, and then negative 4.9 times h square will be negative 4.9 h square. And now we can combine like terms, so h at 2 plus h, so we should start by writing the terms with the highest exponent on the variable, so negative 4.9 h square, and then we have to combine the h terms, so I get negative 1.6h, and then we have to combine the number terms, so 36 minus 19.6 equals 16.4. So this is the expression for h at 2 plus h we should use in this derivative formula. So h prime of 2, so limit h approaches 0, so we get h at 2 plus h is negative 4.9 h square minus 1.6h plus 16.4, then minus 16.4. This is h at 2 over h. Now we can cancel out the 16.4s. So we get a prime of h at 2 equals limit h approaches 0, the negative 4.9 h square minus 1.6h over h. Now we can factor out an h from the numerator. So prime of h at 2 equals limit h approaches 0. So if we factor out an h, we get negative 4.9h minus 1.6 over h. So we can cancel out the h's and we can apply the limit. So prime of h at 2 equals, so we get negative 4.9 times 0 minus 1.6. So prime of h at 2 is equal to negative 1.6, because negative 4.9 times 0 is 0. And the unit here will be meters per second, because that's the rate at which the height will be changing. So this should be the final answer for part A. Now we can answer part B. So we have to find what does h at 2 prime of h at 2 represent. So it represents the rate of change of height of the football at t equals 2 seconds. So prime of h at 2 represents the change in height of the football at 2 seconds, and the rate of change is change of height at 2 seconds is negative 1.6 meters per second, which means the football is not gaining height, it is coming down at the rate of 1.6 meters per second. So we can also add that as part of our answer. So it is coming down at a rate of 1.6 meters per second. So it's coming down because the answer is negative. So it's losing height. So these are the steps you have to keep in mind to solve a problem like this one. So in the first part, we have to find the prime of HA2. So we have to find the derivative of the given height function at t equals 2 seconds. And then we have to write a statement to show what this value means. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.